Good morning everyone. Today we are going to see mechanics of material subject in the unit 1 stress, strain and deformation of solids. We know stress is nothing but a internal resistance offered by the body against external things. The external things may be force, heat or cold. There are some types of stresses involved in the machine materials. That is tensile stress, compressive stress, shear stress. And coming to the strain, it is the measure of deformation related to the original dimension when force is applied. It is expressed as the ratio of change in length to the original length. And the types of strains are tensile strain, compressive strain and shear strain. And this is the example problem for the stress and strain calculations. A mild steel rod is given 2 meter long and 3 centimeter diameter is subjected to an axial pull of 10 kilonewton. If E for the steel, that is Young's modulus for the steel is 2 into 10 power 5 Newton per millimeter squared, find stress, strain and change in length, that is elongation of the rod. So we know very well stress equal to load per area. Substitute the value, get the answer as 14.14 Newton per millimeter squared. And coming to the second formula, we know Young's modulus equal to stress by strain. Substitute the value, you are going to have you know very well that is Young's modulus is given. So do the cross multiply. So we can find the strain as 7.07 into 10 power minus 5. So we already know there is one more formula for strain, that is change in length to original length. So substitute the value of strain in that, and the only unknown is change in length. So keep the thing in the left side and the other things are in the right side. Do the calculation. So you're going to have 0.141 millimeter. And coming to the next topic, stresses in bars of varying cross section. Suppose the arrangement have different diameter and different length. We go for some consideration. So that we are going to see here. So this is the arrangement A, B, B, C, C, D are the three portions having A1, A2, A3, L1, L2, L3, and there is a common axial pull in the arrangement. So consider the first portion. The tensile stress in the first portion is load per area, that is P by A1. The change in length is delta L1 is P L1 by A1E. Same thing for the second portion and third portion. So coming to the total elongation, add all the change in length, that is delta L1 plus delta L2 plus delta L3. So you keep the common thing, that is load is the common thing and Young's modulus is the common thing. So keep the thing in the outside and the formula become change in length equal to P by A into L1 by A1 plus L2 by A2 plus L3 by A3. And this is the example for the bars of varying cross section problem. So here they have given a steel bar of 900 mm length and 3 diameters D1, D2, D3 are given, and the length also given L1, L2, L3. And the total load is given as 15 kilonewton. So you do the conversion of kilonewton to newton. So the question is stresses in each section and total extension of the arrangement. So we know very well the stress in the first portion is stress AB equal to load per area. Substitute the value, you are going to have the stress in the first portion as 11.9 Newton per millimeter square. Same thing, stress in the second portion BC is same load per area, do the calculation. You are going to have 84.8 Newton per millimeter square. And coming to the third portion CD, do the calculation, load per area, you are going to have the answer as 21.22 Newton per millimeter square. So then coming to the total elongation. So we know the formula P by E, L1 by A1 plus L2 by A2 plus L3 by A3. So in that you substitute all the values and find the answer as 0.245 millimeter. And coming to the next topic, thermal stress. Normally you know very well when we heat a metal it is going to expand. Suppose we arrest the expansion, means the stress is going to be induced in the arrangement. That we are going to calculate by some formulas. Coming to the composite bar thermal stress, consider this picture. There is a two metal, brass and steel, both are having same length. Now we are going to heat, means it is going to expand. That is called free expansion of metals. Brass going to expand more than the steel. Suppose we are arresting the ends of the metal, means when we heat, means the brass going to tend to expand more than the steel, but the ends are arrested. So there is a compressive stress involved in the brass and tensile stress induced in the steel. And coming to the elastic constant, this is another topic. We have three elastic constants. One is modulus of elasticity, that is Young's modulus. Another one is bulk modulus. Another one is shear modulus or modulus of rigidity. So we know very well Young's modulus is nothing but stress by strain, and shear modulus or modulus of rigidity is shear stress by shear strain, denoted by C or G or N. And bulk modulus is the ratio of direct stress by volumetric strain. And this is the example for the elastic constant problem. Here they have given length of the arrangement 5 meter, and breadth, thickness, axial pull, Young's modulus of the arrangement, Poisson ratio. So they are asking change in length, change in breadth, and change in thickness of the arrangement. So we know very well Young's modulus equal to stress by strain. So in that you substitute the value of Young's modulus. We also know stress equal to load per area. So that also we substitute in that previous equation. So in that there is only one unknown, that is longitudinal strain. You keep the thing in the left side and remaining thing in the right side. Do the calculation. You are going to have longitudinal strain as 1.67 into 10 power minus 3. And we also know longitudinal strain is change in length to the original length. So you keep the unknown in the left side, there is change in length, and the remaining thing in the right side. So finally we got it as 8.35 mm as change in length. We also know Poisson ratio is lateral strain by linear strain. So already we have derived a longitudinal strain, that is called EL. So that is one of the known value. The unknown is lateral strain. So you keep the unknown in the left side and the remaining thing in the right side. Do the calculation. You are going to have 0.501 into 10 power minus 3 as lateral strain. But lateral strain also known as change in breadth by original breadth, change in dia by original dia, change in length by original length, change in length by original length. So you do the calculation for finding the change in breadth, that is ET, lateral strain is nothing but change in breadth to original breadth. Keep the unknown in the left side and remaining in the right side. Do the calculation. You got 10.02 into 10 power minus 3 mm. Same thing for finding the change in thickness. That is delta T by T equal to ET. You keep the unknown delta T in the left side, remaining in the right side. Do the calculation. You find 7.51 into 10 power minus 3 mm. So that's all today. Thank you.